This workflow is going to look at doing a rain simulation using TyFlow. First of all, I just want to check my unit setup, and I want to ensure that that is set to centimeters. We're going to start with a standard plane, so just under standard primitives, I'm going to choose plane and draw a plane. I'm going to make the dimensions of that 250 squared. And I'm going to bring it to 0, 0 on the X and Y values. I also want to choose a color that's a little more fitting for observing water. So I'm going to click gray. Now I can add a TyFlow. And clicking on the modifier panel, I'm going to open the Ty editor. Now for this simulation, we can start with a standard birth. And I'm going to specify 5,000 particles, and they are going to be birthed over those 125 frames of this simulation. So just coming into time configuration, I've specified 125 frames, and I'm going to click custom. So there's 25 frames per second. That means we're going to have a 5-second simulation. Okay. What I want to do next is just search for a position icon. We want to dictate where those particles are going to be birthed. So I'm going to drag a position icon in and click create new. Now that's going to bring up the Ty icon. And here I'm going to set the dimensions of that Ty icon to 200 by 200 because I want that to sit inside the plane. Now, as you can see, I just drag along here. As you can see, those particles are being birthed throughout that simulation. So what we want to do next is add a speed operand. So I'm going to hit tab and search for a speed operand, double click that. And what we want to do is at the moment, the direction is set to random 3D, which is, as we can see, not very fitting for a rain simulation. So I'm just going to click the drop down tab and select a long icon arrow, and then we're going to pick the plane. Now, if we run through the simulation, you can see those particles are going to fall towards the plane. We do want to increase the magnitude because, as you can see, it's falling a little bit like snow. So we're going to increase that. 10 or 12 should be fine. And now if we observe that simulation, we can see they're falling like rain. But they are going through this plane. So the next operand we're going to add is a collision. And for the collision, I'm going to pick the collision surface as the plane. We're just going to change a couple of factors here. So shape radius and the multiplier. And I also want to toggle with that bounce. It's set to 25, which it's quite high. So we're going to lower that to 7%. Let's just observe the effect first. You can see what happened after that collision. Those particles are bouncing up towards the Ty icon. So we want to reduce that bounce to 7%. And then what we are going to do, we're going to set up a bit of a workflow to dictate what happens after that collision. So I'm just going to click and search for a time test. And I also want to add a delete. Now, if I join these up, I'll then explain what's happening through this particular workflow. So what this is saying is after that collision takes place, if the event age of those particles is greater than the value 2, they're then going to be deleted. So let's observe that in action. Okay, so you can see this color, what happens after they collide. They're around for a little bit and then they're deleted. But we are going to change this color to 1. It's a little more fitting for rain. Okay, what we also want to do is add a force here. So we want to add some gravity in there. And we're going to set the strength of that to -0.2. And we're also going to add a couple of effects for after that collision takes place. So the first one I'm going to add is array. And what array does, it spawns parent particles in a circular pattern. So I'm going to set the offset of that circle to 5 centimeters. And we're going to add some variation, 15. And then we're also going to add a branch, which is going to add some more variation after that array occurs. Okay, now we can watch through the simulation and observe the effect of those operands.